Hi everyone, welcome back. We have already completed the theoretical part of the first chapter, chemical reactions and equation. So here some index questions are remaining. So in this video, we are going to deal with the index questions. First question, why should magnesium ribbon is cleaned before burning in air? We know that magnesium has a capacity to react with air and they form a protective layer on the surface of the metal. Generally, it is a combination of magnesium carbonate and magnesium hydroxide. So, in order to remove the protective layer on the surface of the metal or clean the surface of the metal, we can use sandpaper or we can rub the surface by using the sandpaper. Then the protective layer will be removed. So, we can write magnesium react with air to produce a protective layer, that is a combination of magnesium carbonate and magnesium hydroxide. So, in order to remove the protective layer or clean the surface of the metal, we can use sandpaper. Second question, balance the following chemical reaction. Here, three chemical reactions are given. The first one, hydrogen react with chlorine to produce hydrogen chloride. First we can write the corresponding simple equation for this reaction. So, hydrogen, that is H2, react with chlorine to produce hydrogen chloride, that is HCl. So, the second question, sodium, the corresponding symbol is Na, react with water, that is H2O, to produce sodium hydroxide, that is NaOH plus hydrogen, H2. Then the third one, that is barium chloride, BaCl2, is react with aluminium sulphate, that is Al2SO4 thrice, to gives barium sulphate, that is BaSO4 plus aluminium chloride, that is AlCl3. On the second step, we try to balance the following chemical equations. First one, H2 plus Cl2 gives HCl. First we can count the number of atoms on either side of this equation. So on the reactant side there are 2 hydrogen atoms and there are 2 chlorine atoms. In product side there is only 1 hydrogen atom and only 1 chlorine atom. So in order to balance this chemical equation, we just put the coefficient 2 on the product side. So this equation is balanced. Means here 2 hydrogen, 2 chlorine. Here also 2 hydrogen, 2 chlorine. So first equation is balanced. Then we move to second equation, that is the reaction of sodium and water to produce sodium hydroxide and hydrogen gas. First we can count the number of atoms on either side. Here on the reactant side, sodium atom is 1 and the product side also 1 sodium atom. In the reactant side the number of hydrogen atom is 2, but in product side there are 3 hydrogen atoms. Then in the case of oxygen, there is only 1 oxygen in the reactant side and in the product side also 1 oxygen. So in order to balance this equation, here sodium and oxygen atom are already balanced. Then we have to balance the number of hydrogen atoms on either side of this equation. In order to balance this equation, we just put the coefficient on the reactant side. So here total hydrogen atoms are 4. But in the product side there is only 3 hydrogen atom is there. So here again we can put the coefficient 2. Okay. Then we can count the number of hydrogen atom. Here 4 hydrogen atom. Here also 2 plus 2, 4 hydrogen atoms. Then we check the number of sodium atoms. Here 2 sodium atoms are there, but in the product side, but in the reactant side only 1 sodium atom. So in order to balance, we just put the coefficient 2 on the reactant side. Then we can count the number of atoms on either side of this equation. Here 2 sodium, here also 2 sodium. Here 4 hydrogen, here also 4 hydrogen. Here 2 oxygen, here also 2 oxygen. So the second equation is balanced. Then we move to the third equation, that is the reaction between barium chloride and aluminium sulphate to produce corresponding barium, sulphate and aluminium chloride. First we can check the number of sulfur atoms on either side of this equation. Here on the reactant side there are 3 sulfur atoms are there, but in the product side only 1 sulfur atom. So in order to balance this number of sulfur atom, On the product side, we just put the coefficient 3. So resulting here are 3 barium atoms. But in the reactant side, only 1 barium atom. So in order to balance, we again here put the coefficient 3. Then we can count the number of chlorine atoms on either side of this equation. So here 6 chlorine atoms are in the reactant side, but in the product side there are only 3 chlorine atoms. So in order to balance this equation, here we put just the coefficient 2. So here resulting 6 chlorine atoms. Now again we can count whether this equation is balanced or not. Here 3 barium atom, here also 3 barium atoms. Then here 6 chlorine atom, on the product side also 6 chlorine atom. Then here 3 sulfur atoms, the product side also 3 sulfur atom. So in the reactant side there are 12 oxygen atom, in the product side also 12 oxygen atom. So this equation is balanced. Third question, write the balanced equation and state the symbols of the following reaction. Here 2 reactions are given. The first one, the solution of barium chloride and sodium sulphate in water to give insoluble barium sulphate and solution of the sodium chloride. So we can write the corresponding symbol equation for this chemical reaction. So here barium chloride, solution of barium chloride, that is solution mean which is in the aqueous form, it react with the sodium sulphate in water. That means it's also in the aqueous state, Na2SO4 aqueous, to gives barium sulphate which is insoluble in water, which means it is in the form of precipitate. So we can write the corresponding symbol equation, barium sulphate BaSO4, which is in the precipitate form, so corresponding physical state is solid. Yes. Then the remaining product is sodium chloride, that is NaCl, which is in aqueous state. Then we can check whether this equation is balanced or not. Here 2 sodium atom is there, but in the product side only 1 sodium atom, and in chlorine atom here also 2, but in the product side only 1 chlorine atom. So in order to balance this equation, we just put the coefficient 2 here. So this equation is balanced and we can write the corresponding state symbols for the reactants and the product molecules. Let's look the second part of this question. The second question, sodium hydroxide solution in water react with the hydrochloric acid solution, that's also in water, to produce sodium chloride, that's in water, and water is also produced. So we can write the corresponding symbol equation for this chemical reaction. So here sodium hydroxide, that is in the liquid, that is in the aqueous state, is reacting with hydrochloric acid solution. It's also in the aqueous form to produce sodium chloride, that's also in aqueous state, along with water, that's in the liquid state. So this equation is already balanced. This is all about this question. Next question, a solution of X is used for whitewashing. Then name the substance X and write its formula. So we know that the substance X that is used for the whitewashing purpose, that is calcium oxide. So the substance is calcium oxide and its formula is CaO. Then the second part of this question, write the reaction of the substance X with the water. If the substance X is calcium oxide, so calcium oxide is react with water to produce calcium hydroxide. It's a chemical, that's its common name is silicate lime. So here the substance is calcium oxide. Calcium oxide react with water to produce a single product, that is calcium hydroxide silicate lime. And calcium oxide is also known as quicklime. Next question, with the help of an experiment, show that electrolysis of acidylated water, the volume of one gas is twice than the volume of other gas. So in this question, this experiment, that is electrolysis of acidilated water, we have already discussed as part of our electrolytic decomposition that we have already mentioned in our previous section. So here we can go to the second part of this question, that is the volume of one gas is twice than the volume of the other gas during this electrolysis of acidilated water. So here we can write the corresponding chemical equation for this reaction, that is electrolysis of acidilated water, that is H2O, undergo electrolysis to produce 2H2 plus O2. From this equation it is clear that here electrolytic decomposition is take place and the two products are formed, that is hydrogen gas and oxygen gas. Hydrogen, 4 hydrogen atoms are there, but oxygen 2 atoms are there. The volume of hydrogen gas formed double of the oxygen gas. Next question, when you mix the solution of lead nitrate and potassium iodide. Here lead nitrate react with the potassium iodide. So first we can write the corresponding equation. So the lead nitrate have the formula PbNO3 twice react with potassium iodide Ki to produce lead iodide PbI2 and potassium nitrate. This is a simple equation corresponding the reaction between lead nitrate and potassium iodide. When we look into this equation, here the lead iodide is formed as a product which is insoluble in water, that means it is in the precipitate form. The color of the precipitate is yellow. Now let's look into the questions. The first part of this question, what is the color of the precipitate formed? So here lead iodide is the precipitate formed and its color is yellow. Then name the compound involved. The formed product is lead iodide which is in yellow color. Then second part of the question, write a balanced chemical equation for this reaction. Then we can check whether this equation is balanced. Here only one lead atom is there. Then here also only one lead. Here 2 nitrogen is there, but here only 1 nitrogen. Here 6 oxygen atoms are there. Here 3 oxygen atom is there. Oxygen atom are there. So in order to balance this equation, here we put the coefficient 2 and here also we put the coefficient 2. So this equation is balanced. Then the third part of this question, is this a double displacement reaction? Okay, when we look this equation, this is a clear example of a double displacement reaction because here 2 ions are present, that is nitrate ion and iodide ion on the reactant side. They can be exchanged each other to produce lead iodide and potassium nitrate. So this is an example of double displacement reaction. Next question, why does the color of the copper sulphate change when an iron nail is dipped in it? This experiment we have already discussed in our previous section, and here iron nail acquires a brown color when it is dipped in copper sulphate solution, and the color of the copper sulphate is changes to green color from blue color. So we can write the corresponding equation, that is iron react with copper sulphate to produce iron sulphate and copper. So in this equation we know that from the reactivity series, iron is more reactive than copper. So iron displaces copper from their corresponding solution, that is copper sulphate. So the resulting product is FeSO4 and copper. So this is an example of displacement reaction. Next question, identify the substances which is oxidized and reduced during this reaction. Here two equations are given. First equation, sodium react with oxygen to produce sodium oxide. By definition we know that what is oxidation. Oxidation means it is addition of oxygen. So in this equation, to the sodium, oxygen is added to produce sodium oxide. That is here oxidation is take place. So in this equation it is clear that sodium is oxidizes to produce sodium oxide and oxygen is reduced. Okay. Then the second question, copper to oxide CuO on reaction with the hydrogen to produce copper and water. In this equation, from copper oxide, copper is produced. That means here removal of oxygen is take place. When removal of oxygen take place, it is an example of reduction reaction. So here reduction will be take place and copper to oxide is reduced to copper. Then in the case of hydrogen, oxygen is added and to produce water molecule. So it's an example of oxidation reaction. Here hydrogen is oxidizes to water and copper to oxide is reduced to copper. So in this equation, we know that the substance which undergoing reduction, that will be act as an oxidizing agent. So here copper to oxide act as the oxidizing agent and hydrogen act as the reducing agent in this reaction. Next question, magnesium ribbon burns with a dazzling flame in air and changes a white substance, magnesium oxide. Is magnesium being oxidized or reduced in this reaction? This is our question. So first we can write the corresponding balanced equation for this chemical reaction. That is, magnesium react with oxygen to produce magnesium oxide. So our question is, here magnesium is oxidized or reduced. In this equation it is clear that to the magnesium oxygen is added, that is addition of oxygen is take place. So this is an example of the oxidation reaction. So magnesium is oxidizes to produce magnesium oxide. While you are reading the textbook, in between you could observe all these questions. So all these questions are completely based on the theoretical part which we discussed in our previous sections. So I hope you understand all of this. Wait for another video. Till then, bye.